smart contracts, we are deploying it on the ApeChain blockchain. Is that right? Yeah. So today my session is all right. Hold on. I think I need to record the session.
It has started, so don't worry.
Oh, you are already recording it.
Yes, please.
All right. All right. So my session for today is to take us through integrating our smart contracts onto the front end. Because when you build a smart contract, users cannot interact with it. Maybe you as a developer might be able to interact with it through the command line or do anything you want to do with it. But for people, non-developers, or people who want to know how Web3 works or use the features that you've built with the smart contract, they need a user interface to use it. And before you can do that, you'd have to create a front end for it. And today I'll be taking us through, or we'll be going through how to connect our smart contracts onto the front ends, so users can have access to the smart contracts that we built. I don't know if I'm clear enough.
Okay. Yes, you are clear.
Very well. So to start, I am just going to go straight to the point. We made this staking. We made this staking contract DApp. It's a smart contract, like for staking. And we all know how staking works, right? Hello.
Yeah, we can hear you.
Okay, so we all know how.
So guys, when our facilitator asks a question, you don't necessarily need to respond in words. You can just give him a thumbs up by clicking this, or you give him the love sign. He's the latest man in the building. Then you can even kind of pop him some and
Very
let's
well.
go.
So we all know how smart contracts, staking works. You are putting your money in a pool or your something like that, and then within some days, like either 30 days, 60 days, 90 days period of time, your money, might have grown in profit, and you can take your money plus the profits. So that's what this particular smart contract is done. But because we are not here to discuss building the smart contract, I'm only going to take you through integrating those smart contracts onto the front end. And so before you let me share my screen before. Let me find a way to share my screen. Money recording. I can't even find the button to share my
So
screen.
check the middle, the one with the arrow facing top.
Yeah, present now.
Yeah.
Okay, entire screen. Can you now see my screen? Great. Right, so let's proceed. So we've already built this staking dApp that one can use to what? Stake his money, and then within a period of time, he or she can come and do what? Take the money and then the profit. And after building a smart contract, you get the contract address. We all know that. So after, let me get a way to partition my screen. So my code here, and then the Just give me a moment. Okay, let me just share only my screen. So we know that after building a smart contract, you get the contract address and then your ABIs. So it's the ABIs and then the contract address that you can use to communicate with what? Your smart contract from the front end. It's just like when you create in Web 2, when you create a backend and then you create endpoints whereby you can use an API to call the endpoints. It's the same way with smart contracts. For smart contracts, you get the contract address and then the what? The ABIs. That is what your front end would use to know that this is where I'm talking to, and this is what I'm talking to. And from the front end, we use Ethers.js to communicate with the blockchain through our contract address and then the ABIs. The contract address shows where our smart contract is on the blockchain. And then the ABIs states the functions or the methods that we kept in the contract, in the smart contracts. I don't know if we are on board or not. If you are on board, let me see a thumbs up. Great. So before you integrate your smart contract onto your front end, the first thing you need to do is to create your front end like directory. And it doesn't matter whether you are going to use a framework, either Next.js, React, Vue, any other framework, or even if you are using vanilla HTML and CSS. The only thing you've got to do is get the APIs and then the contract address, and then write the functions or use Ethers.js, which is a library you are going to install, and then you can communicate with what? Your backend. So in this regard, I am using Next.js as my front end framework to communicate, so like to build my front end for the staking dApp. So in the front end, you are going to create a file to create to store the contract info. And in this file, as we can all see it here, contract info. If you click on it and then you go, you're going to say index.tsx. Inside it, I've stored my contract address here. And you all can see your contract address here. And after that, I have the ABI, which is in a JSON-like format. Const ABI and in that order. I hope you all can see it and we are all on the same page. Great. So after getting your contract address and then your ABIs, I think you are almost halfway into what? Integrating your smart contract onto the front end. Because if you understand this, if you understand that, oh, before I integrate my smart contract onto to a front end, what I need is the contract address and then the ABI. Then everything will be easy. The only thing you get to do or know is where to put or where to place those contract address and then the ABIs. So after creating a file and then storing the contract address and then the ABI, the next thing you need to do is to create a configuration of how users are going to connect their wallets. Because we all know that before you can communicate with or to a blockchain, you need a wallet address, because blockchain doesn't store users' information or identify users by their names. It identifies users by what? By their addresses. Are we all on the same page? I would like to see a thumbs up if we're all on the same page and we are following what I'm explaining. Yeah. So, where am I? So, we need a way to configure how our front end is going to connect our wallet. Our wallet, which has blockchain addresses, or which has our addresses. Wallets can have like Bitcoin address, Ethereum address, ApeChain address, and all that and all that. So we need to configure a way after setting our contract address and then the ABI. We need to find a way to configure how our front end is going to connect to our wallet. And we do that by using WAGMI and Rainbow Kit. Let me move to that file, and then use the code to explain it much better to your understanding. Uh-huh. So if you come into this library directory, you're going to see that inside it I have config.tx. I'm using TypeScript for my front end. You can use JS like I mentioned before. It doesn't matter if you are using either JS or TypeScript or any other front end framework. It just depends on you. You just have to find a way to configure your front end such that it will be able to communicate with your backend. So when you come into this config file, that configures how we communicate or how we connect to our wallet. We imported WAGMI. We imported these functions: HTTP, create storage, cookie storage from WAGMI. And then we also imported Sepolia, Arbitrum Sepolia, and Optimism Sepolia from WAGMI chains. I'll explain all that in a bit. We also imported chain get default config from Rainbow Me / Rainbow Kit. So what this functions from this WAGMI that is this HTTP specifies how our app is something like that. I mean, it's a channel of how your front end gets to talk to your smart contracts. And we use the WAGMI library, which provides us with HTTP that allows your front end to communicate with what? Your backend. Pardon me if I'm, missing some of the syntax. We don't keep the syntax in our head, like I always mentioned. And then we also have create storage. The create storage uh, is is being imported from WAGMI, and the create storage tells the browser or where we are opening our front end how it should store the user's connection session. Say, for instance, you connected your wallet. If you connect your wallet and then you refresh your browser, or like you close your browser and then you reopen it, how should your browser be able to remember whether you was connected or not? You can use the create storage and then the cookie storage from WAGMI to configure that here. I'll come that down there. But that's what this function does. This HTTP helps the RPC to helps the RPC to allow the front end to communicate with what? The smart contract. And then this create storage and then the cookie storage ensures that our wallet connection session is stored persistently, even if we close the browser and reopen it, or close our laptop and reopen it. And those functions are gotten from WAGMI. And then we also have Sepolia, Arbitrum Sepolia, Optimism. They are blockchains from WAGMI chains. And these particular three blockchains are imported for us to configure which particular blockchains we are allowing our front end or our smart contracts to communicate with. So if we configure only Sepolia, Arbitrum Sepolia, and Optimism Sepolia in the configuration, then there's no other blockchain can be used within our smart contract because we configure it to not accept anything of that sort. So in this regard, we have Sepolia, Arbitrum Sepolia, and then Optimism Sepolia from WAGMI. That is of which we use that to configure here that our smart contract should only connect to those chains. It should only connect to Sepolia, Arbitrum Sepolia, and then Optimism Sepolia. And like I mentioned, the storage, create storage, and then the storage here. You can see it from the config here. The storage stays like create storage. The create storage creates the storage of where to store, our wallet connection session. And then we got also what cookie storage. And then the create storage is taking a parameter of storage, which is cookie storage. So it is telling WAGMI that we are storing our wallet connection in the cookies. We could have stored it in a local storage or any other storage that is locally within the browser. But in this regard, WAGMI, we are getting the cookie storage and then the create storage to store our wallet connection session in the cookies. And I hope we all know cookies. Yeah, even if you don't know it, after a year, we can all go check what browser cookies are. It's a way to store information in the browser and no other computer can access it, but only the PC or your browser can access it. Even if a different browser cannot access that information. And that is done for security purposes. And in this regard, it is to persist our wallet connection. So that if you refresh your wallet, it will not go away or something like that. And then this SSR is because since we are using Next.js. Next.js is a server-side rendering framework. So this SSR true means that if this code is still running on the server, everything should be working. And then if it's also running on the client side, like we kept this use client up here, everything should also be working. This use client says that all this code is a client-side code. But then this SSR we put here, which is called to true, tells this code that if the code is still running on the server, it shouldn't break. Everything should be okay until it comes to the client, and then everything will work out. And then the chains, like I mentioned here, this is how the chains are configured. Here we created a variable, supported chains, and then we initiated this class, and then that class is gotten from Rainbow Kit, and we use that to create an array of chains or blockchains that we want our smart contracts to communicate with, which is Sepolia, Arbitrum Sepolia, and then Optimism Sepolia. And then we use that supported chains here to pass it into a transport so that no any other blockchain can communicate with our smart contract, unless only those ones that we specified. So that's it over there. So this get default config is from Rainbow me/Rainbow Kit. It's where all this configuration goes in. And then we export it so we can use it outside. So basically, what this WAGMI chains and then this Rainbow Kit does is it helps us configure how to connect to our wallets and then how to persist our wallet connection. We are using libraries. This WAGMI, they are libraries that we use for that. As developers, we can also write our own. But because we are developers and we are lazy, we always need short and then simple means to do things. So we write it once and then whenever we want to do it, we use it. So, but else there are ways you can write this by your own code. Like you just write vanilla JavaScript to help you connect to your wallet, to help persist it and all that. But there are libraries like WAGMI and the Rainbow Kit to handle that logic and then the UI things for us, so we don't need to do it again. I want to see a thumbs up if the explanation is clear enough, so we can move on. If it is not, and anyone has a question, he can raise it up, and I'll maybe explain in detail. All right, so it means everyone is on board. Let's proceed. So after configuring how your front end should connect to your wallet, the next thing the next thing you should do or you can do, and this one is optional, is for you to configure this. You are going to configure this in such a way that if someone connects his wallet, this particular code is going to pick his wallet address, convert it to a hash code, and then pick from, and then when it converts it to the hash code, it's going to pick from this array of avatars and then assign a color and then an avatar to it, so that you wouldn't have to upload your profile picture. In Web3, we don't use our profile pictures, or we don't do that. We don't trust. We verify. And these are the ways that we do what we verify. We take your wallet address, convert it to a hex code, and then from the hex code, we pick an avatar and a color from this avatar array, and then use it as your profile picture. So that is just the purpose of this code. This particular code will be shared to you after the session, and you can all go through it. Or if you've come across it already, then you might be familiar with what I'm explaining. And so this middle ellipsis is what is going to help us get the functions from WAGMI and Rainbow Kit in order to get our account details, account balance, and all those and all that. So let me go to the component directory, and then we can see that in action. So when you come into, I don't know from my explanation, if like we are all like on board. So because so far what I've explained is, in order to connect your smart contracts onto your front end, what you need is your contract address and then the ABI. And then your contract address, you store it in a file. And then inside another file, you create a configuration of how you are going to connect with your wallet. And with that one, we use WAGMI and then Rainbow Kit to do that. I've shown you the code. And even if you just go to Rainbow Kit or WAGMI libraries documentation, if you read it, you are going to even see it and then get it even more simpler than I have explained. So I would want to hear you all say like we are on page, and then you understand what is going on before I proceed. Good. So we have this button, this connect button. In the components, we have a components directory whereby we have a button, and then inside that button we have we've imported several files and then libraries like in the other one. And then inside this file, we imported use connect modal, use account modal, and then use chain modal from Rainbow Me / Rainbow Kit. Oh, that's not much. / Rainbow Kit. And then we also imported use account and then use disconnect from WAGMI. We also imported emoji avatar for address from here, from the one that I showed you earlier on, that we use the addresses and then convert it to a hash code. And then from the hash code, we match it to a color and then an avatar. That is what we also imported here. And then we created we create the connect button. I am sure by now we all should be familiar with React components and the Next.js components. If you are not familiar with React components or Next.js components, let me know. And if you are, give me a thumbs up and let me continue. Okay, I hope everyone is comfortable and understands what a React component is. So inside here, we created this React component called connect button, and then it takes a parameter of set is logged in. It takes a parameter of set is logged in, and then inside that we are getting is connecting address is connected and then chain from use account. And you know, we imported this use account from WAGMI. What this use account means is it's a hook. I don't know if you also know what hooks are in React. If you don't know what hooks are, you give me a thumbs up and then I'll explain it. But if you do, you can just maybe keep it up and I'll continue explaining. Hooks are simply functions. Like it's a function that returns another function that does something. If you don't understand, you can open your microphone and let me know. So I will explain what React or Next.js hooks are. Okay, I hope we are
So
all on board.
guys, if you don't understand anything here, you can raise your hand or just unmute your mic and then talk directly with him.
Yeah, and
So
then
that
talk
we can
directly.
just yeah, that's fine.
Because for some of the things, I assume like you.
So is it only from my side that I have your screen very splitted kind of? I'm sure it's my network, or is anybody to see it
No,
that
no,
way?
no. It's not your network.
It's the same
Okay, it's
thing
like
here.
that. Okay, so it's like there is a split kind of like when in a movie, emotionless, so many things. We have over 100 of your profile pictures, over 100 of tabs, join. You know, it's a very nice design though, like a pyramid. So the screen is not perfectly showing. If you can um, represent, stop the presentation and represent, and we see.
I think he was just trying to like switch tabs. He was working in like a particular tab and then he's just coming to like the browser to view maybe the actions we are given.
Yeah, I'm sure. Zanoli, are you there? His network on his part. Uh-huh. So he will rejoin and then do the right thing. So let's see so that he can reconnect his network and then give Abdullah Yuri, you are welcome. Kabir Abubakar. Okay, he's rejoining.
So
Um,
sorry guys, I
I
lost my connection.
Yes, it's understandable. As far as you find yourself in Africa, these things are bound to happen. You can't skip
Yeah,
it.
yeah.
So the floor is yours again.
All right. So let me continue.
Okay.
So I was explaining that we import use accounts and then use disconnect from WAGMI, and it was WAGMI that we use to configure how we connect our wallets to the front end, and then that is going to what help us communicate with our smart contracts as our backend. So this use account, it returns us is connecting address is connected and then the chain. So what this is connecting means is that if what this is connecting means is that are we together? Okay, okay. Man, stop making noise. But what what this is connecting is doing is that when you click on connect, when we configure when we make our configuration with WAGMI so that it helps us connect our wallet onto the front end, that can help us connect to our smart contract at the back end. It has this function, use account and then use disconnect, and then that use account is giving us is connecting. And what this is connecting is doing is that when you click on connect your wallet, this is connecting is what the WAGMI is use account is going to give you. So you can use this is connecting to display on your front end that to display on your front end to users that when you clicked on your wallet to connect, the wallet is connecting. I mean, it's on process, so you should hold on a bit. And then this address, when you click on the connect, and then you are able to connect, this address function is going to what return your address. I mean, your wallet address for you, so you'll be able to see your wallet address. And then this is connected. It's only going to be true. It's a boolean. It's only going to be true when you connect to your wallet, and then what everything is set, so it's going to be true. But then until you connect your wallet, it's going to what before. And then this chain also returns the chain. Like let's say you are connecting with ApeChain, Arbitrum, Ethereum, or wherever. The chain is going to be stated or is going to be gotten what from this function. And then this emoji avatar for address is also a hook. And then that hook returns color, and then that color we got it like a background color. So the background color and then the emoji, it returns it. So we use that. You see, if you are going to call the emoji avatar address, you'd have to pass it what the address of like a wallet address, because this emoji avatar for address, it takes an address and then converts it to a hash code. It is the hash code that is going to use to pick the background color, the color that I showed earlier on, and then the emoji, and use it as what? As your profile, without you having to upload your profile, because we are Web3 developers. Is that clicking, or I need to explain into detail or more? Let me see a thumbs up if it is going well or into our understanding. Or if not, you can open up your mic and let me know where you are missing. Hello. Hello.
You see?
Hello.
Yeah, we can hear you.
Yeah, are we together?
Yes.
Yes, sir, please, we can hear you.
Yeah, I'm asking, like, are you still following or you are missing? Because, like, the explanation is now going a little bit deeper. So if you miss a point, you can just unmute your mic and then let me know, draw my attention to where I explained past something that you didn't understand. And if you understand, you can just give it thumbs up.
Once again, your screen is splitted.
My screen is
splitted once again. I
Yes,
don't know whether
but
from
because
my
it's
end.
it's the entire screen, that's why.
Is it splitted?
It's back normal.
Yeah, is it splitted?
It's okay now.
No, it's not.
Yeah, I only come back here so that I can see you, and then
Yeah.
when you give a thumbs up, I'll come back here.
Okay. Then that's fine. Go back.
All right. So is the explanation going all right, right? So
Surely.
from the emoji avatar that I showed, we explained that it takes address, and then it takes that address, converts it to a hash code, and then it's going to use that hash code and then pick from the colors that we configured already, and then an emoji. Let me go back and you see it here. These are the colors. These are the colors here, and these are what the emojis. And so, and this is the function that converts our wallet address into what? A hash code. And this is the emoji avatar function. And then it takes an address of a what? String. That's your wallet's address. And then inside it checks if the wallet address is a string. If it's not a string, you should just pass it empty string. And then it now takes the hash code and then resolve it dots to lowercase and then divide it by what, and then just convert it to something shorter so it can pick what the color from here as your profile. So that's what is happening here. So that's the same thing that is happening with the libraries. It's just that with those libraries code, we can't see it, but we know that this use account is giving us is connecting address of the wallet that we use to connect is connected when we are connected, and then the chain, the blockchain that we connected to. That's what the use account is what is doing for us. Let me see where we use this disconnect. So if you come here, you're going to realize that we also imported use connect modal, use account modal, and then use chain modal from Rainbow Me / Rainbow Kit. The WAGMI and then Rainbow Me and Rainbow Kit, they go together. They go together to build the UI and then the logic of how we connect to our wallet. So from here, you can see that this use connect modal, it returns us open connect modal. So if you click on connect modal, this use connect modal is going to bring a pop-up, like it's going to bring the connect wallet modal pop-up, so that you see the number of the number of chains that you have in your wallet, and then you can pick from it. And then this open account modal, after connecting your wallet, if you click on it, it's going to, or if you create a button and then pass it to that button and then you click on it, it's going to show you your account, like say the address, the chain that you are connected to, you are connected, and all that and all that. That's the profile, and that's the account modal. And then the open chain modal is the same thing. It opens a modal that shows you what the chain that you are using to you are connected to. And then this disconnect, I think, is coming from WAGMI, same from the one we get from the disconnecting. So this disconnect simply disconnects your wallet from your smart contract or from your front end. Say you finish whatever thing you want to do, you finish staking, and you want to disconnect your wallet because you don't want things and other things on all of that. You can use the disconnect function, pass it to a button, and then when you click that button, this disconnect button is going to disconnect your wallet from that particular smart contract that you was connected to. And so when we move into the code, Mr. Habib, the time, I hope it is in line. Like, you need to remind me of my time so I'll know how to be explaining my things.
You can go on.
All right.
Yeah, but you have to be a bit summarized and straight so that we can catch up with.
All right. So this is mounted is just a React hook. This useref is a React hook that tells this particular component when it renders. So it tells this particular component when it is rendered or not. So if it's rendered, by default it is false. So if it's rendered, and then it's now going to be what? True. And then inside this use effect is what we use to determine whether it's rendered or not. So when this is mounted changes to true, this use effect is going to trigger a re-render, and then it will re-render that, oh, this component is now mounted, and all that. That's what is happening in this use effect. We all know how use effects work. And just like the functions, I think even if you are going to take things to advanced level, I have explained almost everything. We have a library that helps us connect our wallet to our front end, and then that helps us communicate to the back end. And then that libraries gives us functions like is connecting. It gives us our address, is connected, disconnect, and all that. So the only thing that we need to do is we are just going to write a React code, like maybe a button connect, and then you pass the connect function that this libraries assigned to us to it, and then disconnect. You create a disconnect button and then do that and do that. But let me just give a bit of an explanation below before the time catches us up. So in this use effect, we have is connected. Sorry, we have if it is not connected, then it should set login to what? True. So that it means it means that the user is what? Is not connected. Else set login to what? False. So like it means if you are connected, it should set login to what? True. But then if you are not connected, it should set login to what? False. I don't know if that is clear enough, because I know this syntax is going to be a little confusing. But maybe right after here, if you go and look at this very well, then you try to run the code, you see what I'm trying to explain over there. And then we also have if statements here. Is someone raising a question? So like we also have an if statement here that that checks whether if a user is connected or not, and all that connections is from the functions that we got from the WAGMI. You know, we use the WAGMI to connect our wallet. So everything we are now doing, it's the WAGMI that is doing it for us. The WAGMI has given us functions for us to check those things. We don't have to write those things by ourselves. The only thing we need to write is our UI. But then the WAGMI and then the Rainbow Kit does everything for us seamlessly. So this if statement checks whether we are connected or not. And if we are not connected, it should return a button. And then inside that button, if it is clicked, this is the button. This is the whole button. And this is the text of the button. So the text of the button says that if it is connecting, then it should show that the button text should be connecting. Else, it should show connect wallet. You see? And then here we have an on-click function. And the on-click function says that if connected, then it should disconnect. Else, it should open connect modal. So if it open the connect modal, and then you click on connect, and then it will connect your wallet to the address. Is my explanation over there clear? Great. Because all those functions that we got from the WAGMI, it has simplified things for us. In a normal, traditional app, we would have to build, or you as a developer would have to build those things. But with WAGMI as a library, it provides us with connect, disconnect, and all that and all that. So the only thing you are just going to do is write conditionals to check whether it's connected or it's not connected, and then it's going to bring up the modal, it's going to bring up the wallet, and you are going to connect it. And then the Rainbow Kit is going to give it a good, nice design, and you are not going to have to handle all those things. And then we also have another if statement here that checks whether if it is connected. If we are connected and then we are not on chain, then it should return wrong network. If we are connected, let's say our wallet is connected, but then there's no chain on the like let's say you use an ApeChain address to connect, but when you connected and then you check, there's a function to check the chain. This is it here, and then you check your chain, and then the chain is what? The chain is not showing or it's not there. Then the button should show wrong network. You see, so the button should show wrong network, and when you click the wrong network, it should open chain model. So if it opens the chain model, you can like verify that whether there's really whether there's really the wallet chain that you used or it's just not there. And if you have to disconnect, and then you click the disconnect button to disconnect it. And then down here we have the return function that returns everything for the view. And then inside it we have a div, and inside that div we have this modal, and then when that modal is clicked, it opens account modal for you. If the account modal is not already opened, it opens it for you, and then it shows you like your emoji, like your profile. That is after you've connected your account. So it now takes your wallet address, converts it to a hash code, and then use it to pick your emoji, and then show you your profile emoji. And then here it also shows you the accounts, like it shows that you are in your account. And then there's this button that says that has an on-click handler, and then we pass the open chain model to it. So and then we pass and then it has a text of switch networks. So if you click that button, it's going to bring up all the chains that are in your wallet, or that we set earlier on. You know, we set Sepolia, Arbitrum, Sepolia, and all that. So if you click on open chain model, it's going to bring up those chains, and then you can either change any chain that you want, or you just maintain the particular chain that you want. And that is the connect button. So you see, guys, connecting the smart contract, connecting the smart contract to the front end is not something easy. You can just configure this rainbow, and then if you can configure this rainbow me and then the wag me and then export its configuration to wherever you want to use it, it will be easier for you to just get those functions, and then you create your buttons and just how you want to your logic to be placed, and you'll be able to manipulate it. Because as a matter of fact, this is not the same dApp or a smart contract that you'll be building, but it's the same concept. It's the same concept. If you build your smart contract, you are going to have to connect a wallet, and if you connect the wallet, you are going to need functions to disconnect, to see the to be able to communicate with the methods that you created in your smart contract and all those and all that. So we also have this component that is the header component, and then inside the header component, we imported this. We imported the connect button, the one that we just discussed, and then we 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 placed it in there, and then we also created the use state, this set login, and then pass it inside, and then pass it to it, because we know the connect button takes it takes a parameter of set login. So here we create a use state to determine whether the user is logged in or not logged in, and then the logged in or not logged in is based on whether your wallet is connected or your wallet is not connected, and that particular one helps React to it helps React to render, to know what to render and what not to render, and nothing else, like maybe authentication in a normal traditional app. So the image, this is just a Hacker Boost logo image that is on the page. Let me go and then show you how this button that we've discussed, and then maybe this header looks, and then come and then we'll just finish all these parts and call it, and then I'll give it to the next person. Let me see if I have start the user script dev or CD. Great. So from all that I explained, this was the button that we what? This was the button that we discussed. So from the button, we had disconnect, connect, and let me go back to the button. We had here connect wallet, and it is rendered conditionally. It stated that if from the functions that we got from the use account, if it is connecting, then it should return connecting, else it should return connect wallet. So that is what is here. You see, it's not connecting, so it's connect wallet. But if we click connect, it's going to bring this modal pop-up, and this pop-up is coming from the rainbow kit that gives us the function of use modal and use what. So from here uh, you choose your wallet that you want to connect to, and then you wait for it to connect, and then you connect. So it's connected. So right now that it's connected, this button is just like all these are conditional renderings to render based on what's happening, what happened, and what not happened. So if I click on this, I can copy my address. I can see my avatar here, my profile, and then I can see the short address that it has given to me, and I can see the chain that I've connected to Ethereum, and that was the profile. And I can see disconnect button. And then we also have here switch networks. So the switch networks was also what I explained. If I click on the switch networks, it brings up all the networks that we stated in the configuration. It was Sepolia, Arbitrum, Sepolia, and then OP Sepolia Auroras that I can't remember. I hope you can still remember that. And so that is it. So basically, that's what that part, does. So let's go and then explain all what this part also what does, and then the staking and all that and all that. So we have the header, and then we inside the header we just pass the BTN and that and that and that. So right now we are coming on to the actual actual communication with our smart contracts. If before we communicate with our smart contracts, we are not using WAGMI or Rainbow Kit. We are using Ethers.js. Ethers.js is what helps us to communicate from using JavaScript to our smart contract, which is written in what? Solidity. So up here, we imported Ethers.js, and then we imported use accounts. That is going to give us our wallet address, is connected, and all those and all that. And then we are also going to import our contract address. You remember we configured our contract address before initially when I showed you. And then we are also going to import our ABIs. And this is the imports here. And all these are just variables that we stated so that it can keep our wallet balance, our staking tab, our unstaking tab, unstake value, assets ID, and what. They are just variables, and we all know variables in React. It's like use state. You declare the variable, you write another function so that you can reset the variable later on. And that's what's happening here. And this use account is coming from WAGMI, and we are going to use that to check whether a user is connected or not. And we are also going to use that to check a user's address before we can do any other thing else. I think I wrote the code, and I commented some parts of it out because I wanted to be explaining what's moving on. So I think this part needs to be uncommented, as you can see. Sorry. If address address. Guys, give me a minute to debug my code, and then get back to you. Guys, sorry I had to take all your time. I'm back. My code was going to mess me up, but I'm back. So, like I explained earlier, all these are variables to what? To keep the data that we have from our smart contract onto our front end so we can show it to what? Users. And then when we come here, we have this use effect that will what help us load the contract data from the blockchain. So before we load the contract data, we need a provider, and then the provider is gotten from Ethers.js. We use Ethers.js to communicate with the backend, like I explained earlier. So the provider is what is going to give us the signer and then the contract. The signer is the owner of the contract, and then the contract is the contract itself, like the smart contract that we've written. And so to get that, to be able to communicate with our smart contract from the backend, what we are going to do is we are going to import, where is it here? Import Ethers.js. And then when we import Ethers.js, we are going to create a use effect. We are going to put it in a use effect like this because we want to ensure that before the component mounts, this particular function or this particular part of the code is run so that all parts of the code can then do what? Pick it up from there. So we then the Ethers.js is a class. So we initiate the class Ethers.js.browserProvider.window like things like that. That's the syntax, you know. And then from that we can get the signer. So we can get signer is equal to await dot provider dot get signer, and then we can get what? The signer. And then contract is equal to new Ethers.js dot contract. And then we can pass in our contract address, the contract address that we stored in earlier. This is the contract address. And then we we got it from the smart contract when we deployed it. So we pass the contract address into the contract, into ethers.contract into ethers.contract function. And then we also pass the ABI. This address helps Ethers.js to know where on that particular blockchain where our smart contract is lying down or is located. And then this ABI helps Ethers.js to know what functions or methods are in our smart contracts, so we can call them whenever we want or whatever we want to do. And this signer is the one or is the owner of the contract. And we also pass the signer to the Ethers. We also pass the signer to the Ethers function so that the function will know that, oh, it's the actual owner. That's what that is interacting with what? The smart contract. And you see from here, we have set contract, and then we set the contract to the contract that we got, and then we pass all the things. From the above here, I explained that we these are all variables that we declared, and then we declare those variables because we want to get all the methods or all other things that we define in our smart contracts. We want to get them from the smart contract and then do what? Pass them to these variables, and then we can use these variables wherever we want to use them. If we wanted to use them outside of this particular component, we could have used context or Redux so that we can use it in other components. But because we are using them in this particular component, we can simply use state as the variables to what? To store them. So we have the contract, and then we have set contract. So set contract initially is set to what? Null. So since it's set to null, but then we use Ethers.js to now get the contract. We don't set the contract to what? To the contract that we get. And then, like I mentioned before we do anything or before we start communicating with our smart contract, the first thing that we have to do is connect our wallet. And if we connect our wallet, we'll be able to get our address, our wallet address. We'll be able to use our wallet address to what? We'll be able to use the wallet that we connected to get our wallet address. So, and we use WAGMI. Initially we use WAGMI to connect to our smart contract. And WAGMI gave us functions for us to check our wallet address, our accounts, and then the chains that we are connected to. So it's the same thing here. We are using that function. Where is it? Address. Above here, we are using that use account, and that use account is coming from WAGMI, and it's because we used WAGMI to help us connect our wallet to our front end and then our smart contracts. So WAGMI is giving us the address. So here we are just writing an if statement that if the address is there, and then we initiate a balance, and then inside that balance we use the provider. So the provider from here, from right now from here, the provider is what we are going to the provider is now our smart contract, where we can get all the methods that we have in our smart contract, that we built our smart contract on. So the provider, and then this contract is what is going to be giving us those methods that we've written in there. And this provider.getBalance is a read method. It's not a create method that is going to incur some fees. It's a read method. So if we want to get the total balance in our wallet address, we can use the provider.getBalance and then and then pass in the address to get our wallet balance. So if we get our wallet balance, we can then set the wallet balance to the variable that we declared at the top here. We have set wallet balance, so which is here. At the top here, we have a state variable, wallet balance, and a set wallet balance. And the wallet balance initially was empty string. But right now that we find that we are able to use providers.js to get the balance of our address, we use the set wallet balance to do to set it to it, so that the balance is now going to be in the wallet balance. And then all that is encapsulated in a function, in that use effect. So after all that, we call that function immediately. So in some concept, it's called an ify. We could have just put all this in a bracket, and then just after the bracket, and then we open another bracket, and then right after everything, the function will run itself. It's ify. So right after putting that all in that function, we run it in the use state. So the function is it's just always run before everything else is done, because it's in use state. I think I am a little tired, and I know Mr. Sabia is also in the session, and I would like to delegate the presentation to him from now. Mr. Sabia, are you on the line? Hello. Hello. Okay, Mr. Sabia, if you have the staking contract, I think it's uploaded on our GitHub page. If you can get it, and then I think continue from there, I would be grateful, because actually I'm a little tired. And the time too is kind of not on our side too. My explanations is not it's not fast enough. I can attest to that. But if you prefer me to continue to finish, I think I would be able to do that. I'm just giving a suggestion. I'm waiting for your say.
Hello.
Yeah, hello. Yeah.
Yeah, I think your explanation is just being detailed, and that is okay for us. I don't see no problem with it. So you can continue. Then we see.
All right. Thank you very much. Okay. So before we this is the main component, this staking.css, because this particular smart contract is a staking smart contract. and this is the main component that handles everything. And inside that component, we have a use effect. That use effect runs first before anything else happens on top of that. But before that use effect or like anything happens in the use effect, we need to connect our wallet before, because if we don't connect our wallet, like the application is not even started. It's just like maybe when you are trying to do something and then you've not logged in. But then after you connect your wallet, this is the first function that runs. And then when the address changes, say when you log out, the function is going to run again, because when you have a use effect and then you pass in dependencies like this, it tells the use effect that when the dependency change, it should rerun everything, like it should re-render it. That is React, and I'm sure everyone of us is familiar with that React. So right now we've gotten our contract from the Ethers.js. We get to communicate with our smart contract using Ethers.js. And how do we communicate or initiate the communication with Ethers.js? We just create a variable. We could have we could have named it Nuruddin or Hacker Boost. But then for clarity's sake, we name it provider. And then inside the provider, the Ethers.js is actually a class. So we put the new and then the Ethers.js browser provider. So it gives us everything about the smart contract, so that we'll be able to communicate with our smart contract. So if we get the provider, we can get the signer. The signer is what? The owner of the smart contract. And then we can also get the contract itself, the smart contract itself, from Ethers.js. And we get it by doing new Ethers.js contract. And then we pass our contract address, the ABI, and then the signer. So assuming we had passed like maybe a wrong contract address, and then we try to do something that we have in our smart contract, it wouldn't go on. Like nothing was going to work, because like the address that we are passing it's either this code cannot find it on the blockchain, or things are just missing up, or the ABI. If we pass, or let's say if we go into the ABI JSON file and remove some parts of the ABI, and then we later on try to call a method that we have in our smart contract. So from now on, if we are going to call a method from our smart contract, we are going to call it from here. It's just like when you create an object. Let's say if you create an object called apple, and then inside the apple you have green apple, so you do green is 1, and then you do red is 2. So if you want to see all the green apples, you are going to do apple.green. So all the methods that we have in our contract is now going to be in here. So whatever contract that we want to get, we are just going to do contract, this particular contract dots, and then it's going to give us the method that we want to call. And then if the method is taking a parameter, or it is taking whatever, we'll be able to call it. Let me I don't want us to go to the I don't want us to go to the smart contract, but then I think I would need to show you some part of them when we are going to call or mention some of the methods. So since we've now gotten the provider, the signer, the owner of the contract, and then the provider, that gives us the ability to be able to get everything about our smart contract. You'd have to get this provider first before you get the signer, because you need the signer to pass it to the to the contract function in order to get your smart contract. So you first of all need to get the provider, and then from the provider you get the signer, and then you pass the signer, the ABI, and then the contract address to get what? Your complete contract. And then you can then communicate with your contract with whatever method that you wrote on the contract. So that's it. So, and then I explained here that we are checking, we are setting our balance, like the balance that we have in the contract. And before we check the balance, the code is checking to know whether the wallet address is available or not. So if wallet address is not available, it means there's no wallet is connected. So the function is not going to run. Nothing is going to happen. It's either going to create these errors, and this error, when it creates that error, it's going to log this error loading what and what. And like I said, the function is called here, and then they pass the address variable to it. And when the address changes, the code is going to be rerun. Like this use effect is going to make it re-render because things has changed. And then next on the line is get your wallet balance. And then get your wallet balance is also in a use effect. And inside that use effect too, we have a function called get wallet balance. And what it also does is it checks if there's an address, and then it also checks the types of window that we are in, because we are using Next.js, and like I mentioned before, Next.js is a server-side rendering framework. Next.js can be used in the server side, and then it can also be used in the excuse me a bit. I need to take a break outside. You all have a room. Hello. So, like I explained earlier, Next.js is a server-side rendering framework. So it can be rendered in the server side, and then it can also be rendered in the client side. So before you do anything, you'd have to check. The first thing that this function is checking is checking whether the address is there or not. So if the address is not there, it means the wallet is not connected. And so whatever thing you want to do is not going to happen. And then after checking whether the address is there, it then goes ahead to check if the type of window, whether we are in the server side or we are in the client side. So it checks if type of window is equal to undefined and window.ethereum, then it should do this. So you see, it says if type of window is not equal to undefined. So if type of window is not equal to undefined, it means we are in the client side. It means we are in the browser. But if it was like if type of window is equal to undefined, then that means we are not in what? We are not in the client side, and this code cannot be this code cannot run in the client side. When you are using a use effect, the code can Java use effect code cannot run in the browser. In the server. It can only run in the client side. So it checks for whether we are in the we are in the client side or not, and then it also checks for the address, and then it also checks for the provider that we initiated here. It checks for that provider, and then we check window.ethereum is what gives us the context so that we are able to communicate with our smart contracts. Context is just like something maybe something is in a room, you cannot get that room, but then if you step into the room, you'll be able to get it. So this window.ethereum, which is coming from the provider, is what allows us to be able to get all these Ethers.js functions and all that. And so it asks if all those conditions are true, then it should come inside the function and then also do what? And then create the provider again. And then inside the provider, you should get the balance. So you should use the provider to get provider.getBalance. So the provider.getBalance, the get balance is a method. The get balance is a method that was in what? In the contract, in the staking contract. Let me go and show you a little part of the staking contract, and you see it here. Where's the contract? Here's the contract. So you see in the contract, we have the user's address, the current position, the wallet address, the created dates, and all that. But these are the functions. We have stake ether, we have calculate interest, get lock periods, get interest rate, get position by ID, get position address, close position. What am I missing? Yeah. So this struct, this struct is like a constructor. If you are familiar with object oriented language, it's like a constructor, like where you can pass like in variables. So this Ethers.js browser provider is helping us to get the constructors from the smart contract that we've written, and then it helps us get the balance of the wallet address that we pass in. So say if I have 0.5 Ethereum in my wallet address, and then I use this provider.getBalance, I'll be able to get the balance of the address or the wallet that I have used to what connect to my smart contract. And here we are setting that balance to the variable up there again. I think that thing was done here, and I don't know, I was supposed to get things in order, in line. So we can remove this one here. It's not needed because that's the same thing that's happening here. So we get the wallet balance, and we get the wallet balance because there are some functions that you might have to perform. Like if you want to perform a create function, it's going to require a value, and if it requires a value and then it checks in your wallet and you don't have any funds, that function or that method that you've written in your contract is not going to execute. I hope that is clear enough. I hope so far the class is we are together. All right. And so next on the function, on the functions that we have, or next on the list we now have is calling the methods that we have in our smart contracts. And to call those methods, we declare a function here, and then inside that function, the function takes in the staking length, like the staking length, like how long are you I am really tired. Like how long? Big thanks to Mr. Sabia for always, having to take us through this for like 4 hours and all that. It's not easy to actually be talking for a very long period of time. This staking length states the number of days that you want to stake your money or your crypto, and it's a parameter that is passed to this stake ether. And then inside that function, we have if no contract or no amount. So we have a contract. The contract was what we use this use effect to get. So the moment this particular component renders, then it's going to grab the contract from using Ethers.js. It's going to grab the contract using Ethers.js and then set that contract and then pass that contract to this variable here, to this variable that we use, the use state here. It's going to pass it there, and then we can use that contract everywhere. So inside this take function is saying that if there's no contract, that means like when the component renders and then it runs up to this function, and then this function checks that there's no contract or there's no amount. What is the amount? Yeah, I think the amount was or there's no amount. I was supposed to set the wallet balance to the amount, but then we can remove this no amounts and then put in the wallet balance there. It's still the same. I don't know if that is clear enough. It's just like a point to check whether we have a point to check whether there's money in your wallet or not. Okay, it's checking in the first place if there's a contract, like if there's a smart contract that it can talk to. And then secondly, it's checking the amount. So I'm saying that we can just take out this amount variable that I didn't even make any use of, and then use the wallet balance that we rather set. The wallet, like here, wallet balance. Here we set wallet balance. So from here, we have wallet balance. We can just take out the amount and then use the wallet balance. Do you get the picture over there? Great. So we can use, and then it will check whether there's a contract, and if there's a contract, do you have any balance in your account to stake? So let's get back to the code. So if you have if there's a contract and you have money like in your wallet, it then comes and then creates a try catch statement. This way is like we have what is the lowest form of Bitcoin, is it Satoshi, right? The lowest form of Bitcoin is Satoshi. Like we have cities, pesos. Like so, the lowest form of Ethereum is someone is on the line. Huh? It's way,
Wave.
right?
Yeah.
Yeah. So that's it. Yeah. So we declare this variable called way. I mean the lowest form of Ethereum, and then what is that function? And then here we created that variable here, the variable here, and then we got it from a variable which got ether, and then yeah. So we created this function here. Conversions like okay, yeah, we created these functions to convert whatever you are staking. Like say you are staking 100 Ethereums. I think I skipped this part. I didn't explain it. We created these functions to convert. Let's say you are staking 100 Ethereums. This if you put the 100 like, and then this function takes a parameter which is a string. So if this function takes the amount that you are staking, it's going to convert it to the lowest form of what Ethereum, which is way, and then change it to a number here, and like it returns it. It then does ethers dot pass int, like pass ether, like it returns it like into like the lowest form of Ethereum for you. And then this one too, it converts it from the lowest form of ether to like lowest form of the way to ether. So like that's what those functions does there. Where are we? Yeah. So we have the way here, and then we pick the function, and then we put the amounts. We put the amounts a user is trying to stake, and then put it inside this way, so that the way function will what convert it to whatever amount of way that the user is staking. A user might not be staking Ethereum, right? A user might be staking Ape or Bitcoin or like any other thing. Like though it is going to only be centered around the chains that we specify in order, but a user might not be staking Ethereum or like so this is the function that will convert it to the lowest form of Ethereum, and then it will now then pick then declare this variable transaction. That's a short form of transaction that we made there. It will not pick that transaction and then do contract dot stake ether, and then the contract dot stake ether, it takes a value, stake length, how many days the user wants to stake. Let me go back to the contract. So this was the constructor I was talking about, but these are the methods. All these are constructors to keep are like constructors, like variables to keep like variables that can be passed into a class. If you explore classes, you might get a bit of understanding of this, but if not, it's not a must for you to know it, but just keep in mind that that's what's happening. Let me check this. Hold on, let me check this, please. So we have we have this stake method in our contract, and then the stake method, it takes the number of days that a user wants to stake, and then it is payable. It's a create function. So if before it's executed, a gas fees would would need to what we paid. So it is payable. So that's it. That's what's happening there. So we take we pick our contract. Our contract that Ethers.js helped us got when we pass our ABIs, our signer, and then the contract address. We and then use it to get the contracts. We have stake ether method inside there, and then it takes the length. So after the length, you are going to pass in the value of the ether, or the value of the amount that you are staking. And here, because we are dealing with Ethereum chain, like blockchain, we are converting it to the lowest form of it, which is way. And that this function is what does it for us. So we pass in the amount, and then that amount does it for us, and then we now pass that function into the value of the stake, and then it takes it, and then stake our money for us. I don't know if my explanation over there is clear. If it's clear, let me see a thumbs up.
Um, I don't know if it's the
Hello.
network, but I can't see your screen.
You can't see my screen.
Yeah,
Is
okay.
everyone unable to see my screen? Is everyone able to see my screen? Please let me know. Hello.
Yeah, the screen has been splitted again. Just ask me some, listen.
Yeah. So what we are going to do is let
Okay, it
me
has come now.
So let's just explain this staking method, so that we can maybe hopefully tomorrow or next time we can explain all the other methods that are in the contract. But what I was explaining here is that this function, this two-way, it takes the amount that you are staking, and then convert it to the lowest form of Ethereum, which is way, and pass it as a value plus the length, which is the number of days that you want to stake, into the stake method in your contract, in your smart contract, and then call it. So it then comes in and do await that transaction. This is the transaction that we get there. Transaction dot wait before it triggers. So we are going to optimistically we are going to optimistically give an alert to our users that, oh, your it has been staked. But then even if it has not been mined in the blockchain or verified in the blockchain, we are just going to optimistically do that, and then when later, if it's verified, then everything will be fine. So after staking, we'd have to update, or like make sure the user's wallet address is refreshed, so that he will see that his wallet balance is deducted. The gas fees will be deducted, and the amount that he staked is also deducted. So over there too, we check for the address, if the address is still there, and then we check the window, and then whether we are still in the Ethereum window. If it is there, we then pick our provider, and then we get the balance of that address from the provider, and then set it to the new balance. Like, we have the balance variable, and initially we set it to the balance that was already there. So after he staked it, and then they've taken the gas fees, and then the amount that he's taking, we have to write some code, some if statements to check everything and ensure that everything is a success, and then and then update the balance. So the balance left from the provider is now going to be balance left. So we set it to the string. So we set it to the wallet balance, but then we are doing the balance dot to string, so that it stringifies it. This is just a method to stringify it. And then we set amount to 0. I think this amount is used somewhere below, or amount. Yeah, I think the amount is used somewhere below to for for the alerts and then the display, the displaying of the amounts. So that's where we're using it. But then this balance and then the set balance are coming from the contracts. So guys, I think we need to we can pause here and then hopefully get another time and continue. But basically, connecting your smart contract to the front end is not that of a big deal. After here, we can all go and then check on the documentation of WAGMI, Rainbow Kit, and then what else is that? WAGMI, Rainbow Kit, and then Ethers.js. If you just go and then check there, you are going to see that they are going to explain this thing even more in detail. So it's just like getting your it's just like getting your it's just like getting your smart contract
Hello, Mr.
ABIs.
Nudin.
Yeah, Mr. Habib.
Yeah, so maybe get a place. Let's pause and then close for today. Then tomorrow we can continue.
Yeah, that's what I'm concluding.
Okay.
Uh-huh. So it's just like if you get your smart contract after you deploy it, if you get its ABIs and then the contract address, that's it you need. You are just going to come and store it in your front end code, and then your front end code you are going to use WAGMI and then Rainbow Kit and then connect your wallet. So Rainbow Kit and WAGMI is going to give you your account, your user's address, and what. They are going to give you all that. You are not going to write it. So the only thing you are going to write is just some like React component to put those functions inside it, and then just do on click do this, on click do this, on click do that. That is basically what we are doing. But then we are using maybe use state and use that to ensure that it runs accordingly as to how we want it. I don't know if the class is clear enough and we've achieved something today. Let me see a thumbs up if we've actually understood or achieved something today.
That's great, wonderful. Ima, your hand is up, so you can quickly ask your question so that we can wrap up by 9.
Okay. Thank you, Nurudin. That was like a great one. I wanted to like ask concerning the WAGMI. So if you refer to like the WAGMI dot, there's like an option to like interact with like the contract using like WAGMI. I don't know if you've intentionally just using to like use the Ethers.js, but I want to know from you if like you think the best or your recommendation is to either stick to the WAGMI for like the contract interaction or just use the WAGMI for wallet connection and then use the Ethers.js for like contract like interaction. I don't know if you get what I just asked.
Yeah. You are asking whether one should use WAGMI for both connecting the wallet and then using it to interact with your smart contracts, right?
Yes, 100%.
What there are two different things. If you understand from my explanation, if you use WAGMI to connect to your wallet, WAGMI is going to give you certain functions. Like you'll be able to WAGMI will be able to allow you to see your address, your wallet address. It will be able to allow you to see to disconnect from maybe the connection, and then all the functions that I showed you to disconnect, and then it's going to give you those functions to do those things. But Ethers.js is what helps you to communicate or to use the methods that you wrote in your smart contract. Is that clear?
Yes, yeah, I think yes, that is clear that Ethers.js helps like interact with the contract. But I think if you refer to like the docs, there are I think additional functions provided with like WAGMI that you can actually use to like interact with the contract, such as like use contract rights. So I want to know if with your experience like writing with Ethers.js and then WAGMI, which one do you think you recommend that we should go with? Is it like the Ethers.js or we should just
Yeah,
connect with the WAGMI at the same time use the WAGMI or just use the Ethers.js?
yeah. For someone who needs his code to be, it depends on your specification and requirement. For someone, he wants his code to be consistent, like to be in the same style. You get the point. But for someone, performance is his goal, and for someone, scalability is his goal. So they all take part in before in development. If you are going to develop, you decide what you want in your code, whether you want scalability, maintainability, you want consistency. Else, Ethers.js does better at communicating with what your smart contracts, and then WAGMI does good at what at connecting with with connecting you with wallets and then handling the wallet connections. But if you need your code to be consistent, like with the same style, without having to connect with multiple libraries, you can stick to one. I don't know if you get what I'm trying to say.
Yes, that is.
It's,
I get
it's
that.
it's just the same thing. Like
Thank you.
maybe it's just the same thing like Redux. For some people, you can see someone he's using Redux for state management, but then he's using Tanstack Query for querying his API endpoints. Meanwhile, Redux can also help you query your API endpoints. But for some people, they know that Redux is specifically meant for state management, and then Tanstack Query is it's also specifically meant for what querying your APIs. But for someone, he can say that, oh no, I don't want to have multiple libraries and that. So I'm just going to use Redux to be managing my state, and then to also use it to be querying my backend APIs. So it's the same scenario here. It depends on you, the developer, your requirements, and what you want.
Yes. All right. Thank you. I got that. But one more, So, I mean, best practices as far as like writing contracts or interactions like contract is concerned. What would you say we should go with? We should like blend it SJS and then WAGMI, like how you did it, or that.
I please come again.
Yeah. So I think what I'm trying to ask is for best practices. You said it depends on the developer if you are considering scalability, maintainability, or consistency.
Yeah.
So I would love to know if for best practices sake, if you are recommending that we should go with connecting our wallet with WAGMI, and then with interacting with the contract, we should go with Ethers.js. I mean, you have experience with like doing this stuff. So which one are you recommending? So like you can stick to one and all that.
Personally, for now, what I would tell you is to do what you are comfortable with. But as you grow as a developer, there's a time that you are going to realize that there are certain things that you want to trade off, or there are certain things that you must just do. And by then you are going to be considering maintainability, scalability. But for now, you can just focus on what you are comfortable with or what is easier for you. I don't know if you get what I'm trying to say, because there's no standard best practice.
Yes.
As a matter of fact,
Yes,
there's no standard best practice. In software development, you are going to realize that if you are trying to have, like, let's say you just start to build a project, and then you say that, oh, I'm going to ensure that all the best practices are followed. You're going to realize that at some point, if you have to follow these particular best practices, then you are going to have to drop this one. If you are going to have to follow this, then you are going to have to drop this one. So it depends on, like I said, your preference. But for you, like at your moment, or if you ask me for advice, I would ask you to go for what you are comfortable with. If you are comfortable with using only WAGMI to do all that, that is fine. But if you are comfortable with letting WAGMI handle the connection, and then giving you those functions to handle that, and then Ethers.js to also handle that too, it's fine. Depends on what you are comfortable with.
Okay, that's fine.
Is that okay for you?
All right, guys. Come again.
Is that okay for you?
Yeah, that's okay. And then the project, you said you share like the link to like the project, so we could go
Yeah.
through.
I'll share the links with you. I'll share it on the platform.
Okay, guys, thank you very much for this wonderful session. To our facilitator, we've really done well. And then, Ima, shout out to you for being the gentleman of the house. You joined first, and you are also among those who are concluding. Yeah, that's good. A lone soldier, he's always good to survive the heat. For sure. You were here in the cold, and you are here in the heat again. That's good. So Daniel and the rest, we are grateful for having you guys. So we will close today, and then we will continue tomorrow for the next workshop session. I can see the whole thing is becoming heated. It was argument here and there. I wasn't able to register. Please, I want to register. Now, if I allow them to register, they think maybe it was only the registration that makes everything works. Mr. Nuruddin, you still have a lot to deal with, because we have a lot of registrants out there, but they are not coming to participate in the workshop. So that's one thing. Let's see how best we can sail through. Thursday is coming, and we shall see those who will survive.
Sure.
So yeah. So thank you once again for this wonderful session. See you guys tomorrow, and we shall continue.
All right. Thank you too.
Yeah. Bye bye.
Good. Bye.
Danny. Danny. You, Danny. Baroski.